So guys, today we will be studying about unit blood and immunity. So if someone were to ask you, first off we go with functions of blood, composition, plasma protein. So in hematological investigations, why do we do it? It's basically performed for laboratory and medical because so many bodily dysfunctions reflect through alterations in blood even in the early stage. And what is hematology? It's the study of physiology of blood and blood disorders. Now study of blood physiology includes different study of different components of blood and the formation, role of, and study of blood disorders. So blood examination reveals two fundamental aspects of hematology: whether the bone marrow is producing adequate number of mature cells on hematopoietic lineage, or if development of each hematopoietic lineage is qualitatively normal. If bone marrow is producing enough normal cells and the development of those hematological cells. Now blood. Now adding anticoagulant to the blood in a test tube and then centrifugating it, we get three layers: plasma, buffy coat, and red cell layer. Buffy coat layer is more important as it contains WBC and platelets. In diseases, abnormal cells are found in buffy coat, like LE cells in lupus, erythematosus, and atypical primitive blood cell in malignant or pre-malignant conditions. Buffy coat preparation is also used for detecting bacteria, fungi or parasites within neutrophil, monocyte, circulating macrophages. The buffy coat is more important in this one to diagnose diseases like lupus or any fungi, parasites in neutrophil or bacteria. Functions of blood, we know there is respiratory function, transport, temperature, excretory, water homeostasis, acid base balance, immunity, storage, body odor, nutritive function, and oncotic pressure. Now blood volume. Plasma without clotting factors is called serum. The fibrinogen is converted to fibrin. Serotonin content is high due to because platelets release serotonin during clotting. Now question comes on this plasma protein. Questions can be what are plasma protein and their functions. Okay, so we can first of all we should know what are plasma protein. Plasma proteins are things like albumin, globulin, fibrinogen, right? So first we will enumerate about them and then we will write their function. So first off we will go with albumin. There is something called AG ratio. So AG ratio is usually more than 1, but it is less than 1 in diseases like liver cirrhosis, ischemic liver diseases, etc. So albumin is more in the body, 4 to 5.5 gram, whereas our globulin is 1.5 to 3 gram percent. Okay, 4 to 5.5 gram percent, whereas our globulin is 1.5 to 3 gram percent. Fibrinogen is way lesser than them. You can remember it as 430.3. Right. Now albumin, where is it formed? It is formed in our liver. Its half-life is about 20 days and molecular weight is 66,000. Okay. Now it is now related to albumin, there are diseases like albuminuria, hypoalbuminuria, and liver diseases, kidney disease. This albumin disease basically is due to disease in kidney or in the liver, because liver produces it, and if it produces it more there will be problem. Kidney, if there is function, if there is problem in the filtering function of the kidney, there again will be problem. Albuminuria decreases plasma protein content leads to hypo. Because in kidney disease filtration power decreases, because of which albumin is given that leverage to get out of the body. So because of that it causes hypoalbuminemia in the body, and it leads to edema formation. Now we know albumin is also responsible for the different oncotic pressure, right? So if oncotic pressure decreases, edema will increase. Okay. Now what is globulin? Globulin is formed in the liver. Let's just remember in the liver. And globulin is divided into 3 categories: alpha, beta or gamma. Alpha, beta, gamma. Alpha 1, alpha 2, beta 1 and beta 2. Right. So in albumin's molecular weight was 66K, whereas globulin is more heavier than albumin, like 90K or something. Now function of albumin was to provide oncotic pressure, right? Whereas globulin, it is important in immunity, transport protein like ceruloplasmin, which is important for our iron transport. Then transferrin again in iron transport, and homopexin, whatever. So transferrin and ceruloplasmin, you should study about that in biochemistry. And globulin also forms lipoproteins in combination with lipids in plasma. And then antibodies are formed by gamma globulin. Now alpha and beta are mainly responsible for transport, whereas the gamma is responsible for immunity. Okay, now their clinical A.G ratio, it is usually 1.5 to 2.5 ratio 1. In many diseases it is altered. Prognosis, it is important. Okay, Now fibrinogen, we know fibrinogen is a plasma protein, molecular weight 34. It is densest, it is like 340 k molecular weight. It is also produced in liver and blood coagulation. It also contributes to viscosity of plasma and viscosity and determination of ESR. Yes, erythrocyte sedimentation rate, and it is fibrinogen is important for that. ESR, when ESR, now very important thing, fibrinogen determines ESR, but it is it's a paradox in high altitude. Usually fibrinogen increases, ESR increases. Okay, but at high altitude, when a person comes from plane to the high altitude, usually there, because of hypoxic condition, erythropoietin is increased or secretion is increased, because of which RBC production increases. Now at high altitude fibrinogen also increases, okay, but it does but at high altitude ESR decreases. This is the paradox. Now its explanation is given such that the RBC cell value is so much that they repel each other and overcome the clumping effect of the increased fibrinogen. Okay, so because of that it does not clump, but rather ESR decreases. Now function, from albumin we know for osmotic pressure, it gives the oncotic pressure. Normal oncotic pressure is about 25 mm of Hg, and maintaining this. And then fibrinogen gives viscosity, globulin gives transport and immunity, and fibrinogen gives coagulation, viscosity, immunity, coagulation, transport we have done. Then elimination of ESR, right? It also, protein buffer. Albumin and globulin act as protein buffers. Okay, remember that. This was our now bone marrow and hemopoiesis. Now for hemat practicals, we should know about these things in detail. Let's just say at least you should know an overview of them all. Now types of bone marrow. There is red bone marrow. The teacher can ask, the examiner can ask you where are the red marrows located. So red marrows are located in the sternum, in the long bones, skull bones and vertebrae. It is yellow marrow. It is for fatty degeneration. It is yellow bone marrow is basically, suppose this is your bone, this is the red bone marrow, then this is the yellow bone marrow. This keeps on decreasing with age. It is very, yellow bone marrow is yellow in color, less cellular, contains more fat cells in all bones except ends of long bone and axial skeleton, except ends of long bone. And white marrow, it is present in very old individuals. Now bone marrow examination. Now bone marrow examination indicated in complex hematological disorders, malignant hematological condition that require eternal cellularity and activity of marrow. Bone marrow examination is done for the following types of assessment. Bone marrow examination is done for number of lymphocytes, state of erythropoiesis, cellularity of marrow, Is it hypocellular, hypercellular, normocellular, normo, hypo, hyper, then number of lymphocytes, then plasma cell, then iron stores. Is iron stores, plasma cells, then number of lymphocytes, then state of erythropoiesis, lymphocytes, number of lymphocytes, are they increased, decreased, or normal, state of erythropoiesis, is it megakaryopoiesis or myelopoiesis, right? Indication of bone marrow examination. Bone marrow is a differentiation of leukemia. When do we do bone marrow examination? In anemia. We do it in anemia to check iron storage, and then for differentiation of leukemias, multiple myeloma, agranulocytosis, megaloblastic anemia, thrombocytopenia, panic purpura, thrombocytopenic purpura. There is assessment of iron stores. Now hemopoiesis. Hemopoiesis is basically the process of formation of blood cells. It can be leukocyte, platelets, or RBCs. Stem cells can be of two types. Myeloid and lymphoid stem cells. Progenitor cells. The progenitor cells develop from the stem cell, okay, and the progenitor cells differentiate into CFU, colony forming unit, CFU for granulocyte, erythrocyte, megakaryocyte and monocyte. Granulocyte, erythrocyte, then monocyte for our lymph, B or T and N. someone asks you what's the precursor of neutrophil, you say myeloblast. Myeloblast is the precursor of neutrophil and monoblast is the precursor of monocyte. Okay, then CFUMG megakaryoblast. Precursor is always blast type and then site and then cell. So myeloblast, monoblast, megakaryoblast and pronormoblast. Right. The types of by the regulation of hemopoietic growth factors, erythropoietin, colony-stimulating factors, interleukins. Interleukin 5 is for eosinophil and 3 is for basophil.